After the completion of slow sand filter, now the next important filter that we are going to start is called as a rapid sand filters. Okay, now so start writing the points. It is similar to the slow sand, only the thing is rate of filtration is higher. So what is the rate of filtration for rapid sand filter? It is 3000 to 6000 liters per hour per meter square. Now if you just see the value of slow sand filter rate of filtration, so that value is 100 to 200, see 100 to 200 liters per hour per meter square, and this is 3000 to 6000. That means if you multiply this by 30 you will get that value. So this value is 30 times that of slow sand filter. So you can remember it like this, okay? Or maybe this can be asked as a question, that the rate of filtration of rapid sand filter is how many times that of slow sand filter? It is 30 times. Okay, so another point from the rapid sand filter is area required is less. So in less area this slow sand filter we can occupy. Now what is the efficiency? So efficiency of rapid sand filter is 80 to 90%. So it is less efficient as compared to slow sand filter. So as the efficiency is less, so in this pre-treatment and post-treatment of water, is mandatory. See, in slow sand filter there is no requirement of pre-treatment and post-treatment. The slow sand filter is itself a one-man army, that if you just pass the water through it, almost 99% you will get the pure water. Whereas in rapid sand filter, as the efficiency is less, so we have to subject the water to pre-treatment and the post-treatment. Now the next point is components of a rapid sand filter. So the first component is same filter box. So this filter box, it is same open, watertight, rectangular tank. Now what is the area for this? Area is 10 meter square to 80 meter square. Then depth 2.5 meter to 3.5 meter, and bed slope is 1 in 100. So these are the specifications for the rapid sand filter, that also filter box. See, this we already discussed, so we won't be taking much time now. You can just go to the previous video to understand what is the filter box and the other things. Okay, the next is filter media. So in this case also clean river sand, that we call silica sand, is used. What should be the thickness? So thickness should be 60 centimeter to 90 centimeter. What is the effective size? Effective size of particles. So this effective size, it is denoted by D10. So what should be the value of D10? It should be 0.35 to 0.55 mm. In case of slow sand filter it was 0.2 to 0.35 mm. So effective size is completed. Then uniformity coefficient. So this is Cu, and it is calculated as D60 by D10. So this value comes around 1.2 to 1.8. Now there is one note that is important in slow sand filter. In slow sand filter, if you remember that only the topmost part, that is topmost filter media of sand, it is washed. Why it is only washed? Why not the gravel bed is washed? Because the topmost sand only plays an important role in the cleaning process. But in case of a rapid sand filter, the entire filter media and the gravel box both plays an important role. So you just write it down. In slow sand filter, only only top 3 centimeter layer plays the vital role. Plays the vital role. Whereas in rapid sand filter, all the layers, all the layers, all the layers plays an important role. Okay. So when we have to clean the slow sand filter, we were using a method which is called as scraping. Why only scraping we are using? Why in scraping only top 3 centimeter of soil we were removing, and if we were replacing with the clean soil, that method is called as scraping. We were using that because only top 3 centimeter plays the vital role in filtration in slow sand filter. But in rapid sand filter, all the layers plays an important role. So we cannot use the scraping in this case. In this case, we'll using a different method of cleaning that is called as backwashing. So we'll see it in the cleaning component or last topic, that is cleaning of rapid sand filter. Now the next point here is the gravel bed. So what are the specifications for a gravel bed? So same thing, it supports the sand bed or filter media. Okay, and it prevents any sand particles to flow along with water. So what should be the thickness of gravel bed? The thickness should be 60 centimeter to 90 centimeter. Okay, filter box, filter media. Then this third is gravel bed, and the fourth one we'll talk about under drainage system. Under drainage system. So same thing as we have seen in case of slow sand filter. So there is a system for the collection of water. So it consists of a central drain. Then the central drain is connected to the lateral drains. And this lateral drain is having certain openings, circular openings. This is called as perforations. Okay. Now, if you just look at the side view, it will just look like this. So this is the main central drain. Okay. To this central drain, there are these lateral drains which are attached. So this is the central drain. This is lateral drain. Now above this there is a gravel medium which is present. So these are the gravel media, and what is present above the gravel? Filter media. So gravel, and above gravel there is sand bed. And this water it enters when it is traveling from sand bed, then it travels through the gravel bed, it gets filtered, it enters to the perforations in the lateral drain, then it gets entered into the central drain, and once it gets into the central drain, it is taken to the outlet. Okay, so what are the main functions of central under drainage system? It is to collect the filtered water, to collect the filtered water, and the second is to clean or backwash the filter. Now we have seen in the previous slow sand filter that the water enters from the sand bed and then gravel bed, and then it comes to the lateral, and then it moves to the central drain. But in case of rapid sand filter, this lateral or under drainage system is designed in such a way that if the water is given inside, let's say if I am closing this inlet has been closed now, and instead of taking the water inside, I am supplying the water with force inside this central drain. Okay, I am applying some pressure to the water and the water is forced into this. So what will happen, the water will then move to this lateral drain and it will start coming out from the perforations. So the water will then come out from these perforations and it will occupy in this filter box. So as the water will start occupying in this filter box, this filter media, that is sand bed and gravel bed, this will come in suspension of water. So due to this, there will be the cleaning of total filter media, and this cleaning is called as backwashing. Okay. So the process, if you have understood, then very good. Otherwise, you just take the video backside and then repeat it again. Okay. So all the water is supplied in backward direction through this central drain, lateral drain and perforations. This makes this filter media into suspension. Okay, so there is complete water now here and it is in complete contact with water, and due to this becoming in suspension, there is the cleaning of the sand bed and gravel bed. So this is called as backwashing of rapid sand filter. Now, so for this under drainage system, there are certain design parameters that we have to understand. So we'll just write it here only, or we just, okay, we'll take it on the next page. So design of under drainage system, under drainage system. So the first formula is total area of perforations. Total area of perforations. So this is equal to 0.2% of area of each filter. Second, total area of laterals. Total area of laterals is equal to 2 into total area of perforations. And the last one is total area of central drain. Total area of central drain. So this is equal to 2 into total area of lateral. So there is one check which is present. So once you design it, so you should check this, that the length of lateral by diameter of lateral, length of lateral by diameter of lateral, it should not be greater than 60. Okay, so these are the design parameters for under drainage system. Now we'll quickly draw the diagram. Okay, so this is a storage tank. Then here there is an under drainage system. So this we all know. Here is a gravel bed. And above the gravel bed there is filter bed, that is filter media or sand bed. Now to wash this topmost layer, there are certain arrangements or sprinkler arrangements present. So that is called as wash water troughs. So this is nothing but a sprinkler arrangement. Okay, so these are called as wash water troughs. So is the inlet. The water comes from here inside. Okay, then water goes to this topmost layer. Then it slowly gets filtered, enters into the lateral, then center drainage, and then comes it here. Okay, now there are certain valves which are present here. So there is one valve which is present here. Okay, this valve is there, and even at this point there is one valve which is present. It is connected to a pipe, and then this water is collected in a separate reservoir. Okay, so now pay attention. See, during cleaning process, we all know, as we have seen in rapid sand filter, initially we'll give these names to the filter. See, this is A, B and C. So these are the valves. So we can open and close these valves. These are called as valves. We can open and close based on our requirement. So initially the water comes from the inlet, it gets filtered, and once it is getting filtered, what we are doing, we are closing certain valves. Which valves we are keeping closed? We are keeping valve A as closed and we are keeping valve C as closed. So water cannot go in this direction and water cannot go in this direction also. We will open only one valve, that is valve B. So water can pass through here. So the collected water will get collected here. It will not go here also, it will not go there also. It will start getting collected into this collection basin. Okay, so this is a filtered water. Once the filtration process is completed, now what we are doing, we are closing B. So we are closing this B valve now. So this B valve is closed now, and we are opening one more valve. We are closing A also. So we are keeping closed A valve also, and we are opening C valve. So what is happening when we open the C valve? Whatever the backwater storage is there, so you can see that it is present at higher level. So this water will start coming down, or we can say the water will start entering through this valve C. As it cannot go through A and B, there will be pressure generated here, and it will start going in the opposite direction from central drain to the lateral drain, and then it will start coming into this gravel bed and the sand bed. So due to this backwashing, or due to this back supply of water, there will be this filter media will be in suspension, and that filter media will get cleaned. So this is called as the backwashing of a rapid sand filter. So in slow sand filter we were using scrapping, whereas in rapid sand filter we will be using the backwashing method. Okay, so filters are operated. So give the heading cleaning of a rapid sand filter. So cleaning is done by backwashing. Okay, so filters are operated till. So one of these two conditions should meet. So first condition is terminal head loss. Terminal head loss is equal to 3 meter, or turbidity is equal to 2.5 nt. Okay, so everything about the backwashing we have seen. So you can just repeat the video and write down the points, because I have explained it 2 times now. Now for the backwashing there has to be one parameter which is called as rate of backwash. Rate of backwashing. So these are asked sometimes and the calculations related to it. So the formula for rate of backwashing is, so we'll denote it with VB. So rate of backwash is equal to VB. So this VB is equal to settling velocity into NE to the power 4.5. So this N stands for porosity. So where this Vs is settling velocity. So by Stokes law you can calculate it, or maybe it is given, then you can use it directly. And this Ne stands for porosity of expanded bed. Okay, so with this you can calculate the rate of backwash. So these are all the formulas and concepts related to rapid sand filter. So there is one concept that is about the operational difficulties, that is the operational difficulties in rapid sand filter. So that we will discuss in one separate video, but overall all the concepts are covered in this video.